Alrighty, we are going through exercise 16D, and in this video I'll be answering question 2, which says cardiac output is an important factor in athletic endurance. The graph shows a stress test graph of cardiac output measured in liters per minute of blood versus workload measured in kilograms meters per minute. The first thing that we need to do is estimate the average rate of change, of cardiac output with respect to workload as the workload increases from 0 to 1200 kilograms meters per minute. Alright, so we need to find the average rate of change between 0 and 1200, from 0 to 1200. So what we're going to do is we're going to draw a secant, a line through these points that we've been given. Those points being 0, so that's going to be this point right here, and 1200, which is going to be this point right here. Now, as you can see here, at 0, my y value is going to be 5, so it's going to be 0, 5. And then up here, it's not going to be quite as easy. It's quite obvious that this is going to be 1200, as we've been told. But my y value is a little bit below 20, so let's just say it's 19. And let me see if I can do a better bracket than that. Perfect. Now what I'm going to do is I'm going to draw a line through these points. So let me grab this and let me put a line through these points as so. Having done that now, we need to find the average rate of change between these points. So what we're going to be doing is we're going to be finding our rise over our run. So let me write that down. We're going to be finding our rise over run. The rise is going to be this distance right here. So to find that, what we're going to do is we're going to go 19, and actually let me make let's do this. It's going to be 19 minus 5, and let's put the units. We're dealing with liters minutes here, so let me just put liters per minute. And then we're going to divide that by our run, which is going to be this distance right here. And as you can see, this is going to be between 1200 and 0. So 1200 minus 0. And our units here are this. You might be thinking to yourself, why do you care about the units? But the units are going to become important in our final answer. Minute. Perfect. Having done this now, what hopefully you can see is that because I have both minutes on my numerator and my denominator, I can actually just ignore them. And then I can just do some working out here. I'm going to get 19 minus 5, which is going to be 14. And I have liters here. And then on the bottom, I'm going to have 1200 minus 0 is 1200. And then I'm just going to have kilograms meter. When I put this into my calculator, 14 over 1200, I get 0.01166666667. So I'm going to turn that into 0.012, and then I have liters per kilogram meter. And that is going to be my final answer. I'm going to get my highlighter, and that is my answer to part A of question 2. Hopefully that has been helpful to you. I'm going to pause here and then record another one for part B. Hopefully that's helpful to you.